Hello everyone, my name is Benedict Kimotuo and I'm a student at College of Informatics and Virtual Education at the University of Dodoma. I'm pursuing Bachelor of Science in Computer Engineering, 4th year, and as in front of you are my group members. At the left corner, Melanie Elberic, Boy Manuel, Kulo Kasambala, Ngonja Peter, and Kombe Nelson. And in front of you here, it's our final year project. It's called Waste Collection Bins Threshold Value Notification System based on GSM. It combats the problem of overflowing dust bins due to untimely and irresponsible disposal of waste by municipals. So I'm going to give you a little bit descriptions of how the system works. So in front of you, we are using an ultrasonic sensor which detects blockage of ultrasonic waves. So the ultrasonic sensor consists of a transmitter and a receiver. We have two threshold values, the normal of 50 centimeter and critical of 40 centimeter. So when the dust reach a distance of 50 centimeter from the ultrasonic sensor, it's going to send a message that the dustbin is about to overflow. When it reaches a distance of 40 centimeter from the ultrasonic sensor, it's going to send a message that it has overflowed. We have programmed the microcontroller to send message to 3 people: the driver responsible on that day, the superior driver, and the manager of the solid waste disposal management department. So we are using a GSM over here. We are using an Airtel chip which sends an SMS to those 3 people as said before. We have our microcontroller, a T-Mega PU328. We have voltage regulator for regulating voltage. As you see here, we are using a solar panel for charging the rechargeable battery. The chargeable battery is having a voltage of 12 volts, so it's going to supply 12 volts up to the PCB, of which the 12 volts is going to be supplied parallel to 2 places, one to the power supply responsible for the microcontroller, and another to the power supply responsible for the GSM. The GSM requires 4.5 to 5.5 voltage, operating voltage, so we are supplying about 5.8 volts. And for the GSM, it requires at minimum from 4.5 to almost like 5.5. We supplied a voltage of 4.9 volts. We're having a LED on each part of the power supply to indicate that power has been supplied effectively. We're also having a LED here, blue one, for indicating blockage of ultrasonic waves. So we're having a switch here for switching on and off the supply of power to the PCB. We're having oscillators, capacitors and resistors for different purposes regulating the voltage. We're having a push button for resetting the PCB. And so this is the packaging. And here, as you can see, this is the waste that we have put here. So I'm going to let someone else to come and show the demonstration.
Actually, now we are on the part of demonstration. So for the demonstration part, I will start by switching on the system. So as you can see now, the system is on. You can see the indication as explained previous that there is these 2 LEDs for the power supply. It shows that they are on. It means the power supply functions correctly. And you can see here the GSM has already powered on, and we'll wait some few seconds for the signal to pick up. Yes, it did. Of course, it picked the signals. Now you can see there is this one, the blue LED. As you can see, it is fluctuating because of the garbages that are not full packed. So I will try to make sure that they are full packed for the aim of sending the text. So you can see now the LED is full. This, the blue one I'm talking, that is full lighting. That it means the garbage bins, it is on the maximum value that has to be collected. Now we are waiting almost for the 1 minute in order to receive a message from this smartphone, different phones, that from the truck driver, from the management, and also one for the superior driver. So we can see, yes, the message has been received here. Now you can see the message we are having right now. It indicates that it is, we wrote it in Swahili, that is manispaa ya Dodoma, Makole jaa namba 1, eneo Makole kwa Gido, taarifa jaa namba 1 linakaribia kujaa, linatakiwa kutoa uchafu. So it means it is full, it has to be collected. So the aim of the system is to make sure that we don't entertain the overflow of these garbages, because we have experienced in several cities of ours, especially here in Dodoma municipal, we have experienced that there is overflowing due to it makes the environment unconducive and also will contribute to several eruption of diseases like cholera. So this system is it is needed so much at this time, so that's why we are recommending it for different purposes, so as needed as possible. So that's the system. It is GSM based.
GSM based notification system threshold value.
Yeah, thank you.
Thank you.
Hello, my name is Ibrahim Yuni. I am a student studying computer engineering at the University of Dodoma, College of Informatics and Visual Education. I am here to present to you what we have developed or designed as students of College of Informatics and Visual Education in the University of Dodoma. Me, or we, meaning me and my team, other colleagues of mine studying at the same university, the same college, we created a CNC router. Here, as you can see, this is a CNC router created by us. There is a project called the iCreate project, whereby we decided to call ourselves so as creating this wonderful CNC router. As you can see, these are the rails that it can travel. A CNC router is used to cut or draw just instruments, piece of board, whether a metal, using automatic controls. This is the automatic control. As you can see, we designed it ourselves from the scratch, together with the rails and everything and how it works, it functions. And its Arduino Uno board is also designed by us. So here is a complete CNC router. These are the motors that can help it move at its rails sideways. These are the tires that can help it move forward and backwards, as you can see. And this is actually the pistol that actually draws. As you can see, this is the header. So you can put anything here, whether it's a board and you want to draw it. So you just take the piece of drawing you want in a USB program, plug it in the controller, and let the CNC do the work. It can work, it can draw, and it can complete your work immediately. So what we have learned here is to try and improvise. This is the cheapest CNC router we could actually make. We just took some few scraps, things that were already used, like the motors, and we designed something pure, like the CNC router, with very simple and very cheap components. What we learned here is how to improvise, how to use the nature, as you can say, to boost our creative abilities. Like, we have problems. People think that advanced technology needs to be done in very advanced materials. No, we decided to use very cheap materials, self-made materials from the scratch, just to develop this simple CNC router. So, welcome to iCreate, welcome to UDOM SCIVE, College of Informatics and Visual Education, and join us in keeping the technology forward. Thank you.
My name is Erna Mwende, pursuing Bachelor of Science in Computer Engineering at the College of Informatics and Visual Education in UDOM. Today we did our final presentation on our final year project. Me and my group, we did a project, we developed an automatic water meter reading system using GSM module, where we developed an automatic water meter reading which takes the readings and sends the information directly to the water authority, where we also developed a system which calculates the bills and sends the information after the required time. Maybe it's after a month or 2 weeks, sends the information directly to the customers, where a customer will be able to pay the bills based on the information that they got. At Informatics, I learned a lot in my 4 years. Mostly, I learned about programming. I did a lot of programming, and I think that's the most thing. The biggest thing that I've learned here.